So in this reaction, we're going to be doing conversion of aldehydes into alpha amino acids, or the Stecker synthesis. So the cool thing about this reaction is that we're going to form an amino acid. So in this reaction, we're forming valine. Okay, how is it going to happen? It's really simple. It's actually, if you look at the previous playlist on about all the reactions, like these type of reactions with like NH4, it's really the same thing. Okay, how it's going to work is NH4 is going to like dissociate whatever from CN, and we're going to have ammonium. Okay, so we're going to have ammonium right here. It's going to have a plus. Okay, so we're going to activate the carbonyl. So just acid base. And now we're gonna have a positive charge on oxygen, and we're increasing oxygen's withdrawing ability, increasing its electron density. Draw a resonance structure here, push electrons on oxygen. Plus charge on carbon now. Now our carbon is super reactive, and what's our nucleophile? Which nucleophile is gonna attack? It's gonna be NH3. So NH3 is gonna attack right there. So if I draw NH3 as a lone pair to attack, it's gonna attack right at that carbon. And so now we're gonna get this is nucleophilic addition. So we're gonna get our nitrogen is now going to have a plus charge, so now we're going to have to deprotonate this nitrogen. So what's going to deprotonate it? The thing we have in the thing, right? The ammonia. I don't know the difference actually, but ammonia is going to deprotonate it. So now right here, there, on nitrogen. Now we can go step 4. What's going to happen? It looks like we're going to have our thing right here, right? It's going to be N and then H. So our goal is to make a carboxylic acid. We have our thing. Our goal is to make a carboxylic acid, and so right now our O is our OH, and so I don't know why I'm not able to think fast. Okay, we have our OH right here, and so now we're gonna want to we're basically gonna want to kick him out, and so what we're gonna use is we're gonna kick him out. We're gonna just use what do we form here? We formed NH4, right? So we have NH4. That means it has a plus charge on it. And it has hydrogens, whatever. We're gonna make that. We just want to get this into water. We just want to turn this into water. And so how it's gonna work is that it's gonna turn to water, and it's gonna leave on its own, unimolecular loss. And so now it's gonna leave on its own. And so what's gonna happen is if it leaves on its own, then we're gonna have a plus charge right here. It is a delocalized charge, so we could just draw some resonance structures, push electrons onto it, and so now. But even then, you don't even need to show all that because that's already the minor product. And so now this is the main point of this entire like reaction. What's the difference between the other like reactions into amines or enamines? We have this CN. That's the big thing. We have the CN right here, and that's going to be doing the attacking. So right here, if I draw in CN, he's going to attack. He's going to attack that reactive like carbon, right? He wants the bonds. And so now, if you were to draw that right here. Our new carbon right here. I need to draw this correctly, SP. So now we have this NH right here, and so now we're gonna have this bond right here. So NH2CN, and so our final step we're gonna use H2O. I think it's H2O twice. I'm not really sure. I'm actually edit this video later on. And then this is gonna just somehow turn this into the the answer. I don't know how it does honestly, but yeah, that's the carbon is the alpha carbon, and then amino acid will have like it'll have that, and then it would be NH plus somehow H2O. Honestly, I don't even get it, but like the final step, right? Like H2O, SO4. I'm gonna write it right here. This makes the most sense, right? I think it's just some hydrolysis crap, and then all of this not hydrolysis, like hydration, and then plus the enantiomer if you want to write it right. So this basically turns into a carboxylic acid, and yeah, it's really that. Even I don't really get the last step. I don't think I'm supposed to even care about it. Yeah, so just make sure you draw that plus sign here. So this thing is this is a reaction into an alpha amino acid. This is alanine.